Okay, so in this video, we're going to take a look at the Titanic dataset using tidyverse or suite of packages. We're going to call up the Titanic3 dataset. We looked at that a little bit before. What was included in the dataset, the 14 variables, a little bit what the dataset looks like. To get some additional maybe insight into that, you can follow this link here. The R documentation here possibly gives a little bit more formal and detailed background regarding the evolution of this data set. It has changed a little bit over time. So it's worth noting perhaps before we get into the Google Colab here and run both R and Python scripts in the same Google Colab, what the context is. We hope to produce a few graphs doing some basic statistical analysis, kind of exploratory data analysis side here, and then finish up with a correlation matrix. Okay, so to get into the Google Colab doesn't require anything more than just a double click and it opens up. We can go full screen here and we can give ourselves plenty of space. And Google Colab is great because you can run not just Python, but you can run R and other languages as well, programming languages. To activate R, you need to load in this command. It's very straightforward. So if you're starting this from scratch, it would be suffice just to copy and paste that command in. And then if you have some R scripts, just remember to put the double percentage sign and R as the first line in the command, and then it allows you to execute R code. I've already installed the tidyverse suite into this Google Colab, so don't need to run that again. When I run library, it should just make available in this environment the ggplot2, dplyr, tibble, tidyr, reader, forcats, stringer. So that suite of packages, which is really handy, is now available. But if you run this, don't see these packages appearing, maybe remove the pound sign here and then run again, and it will do a full install. Okay, so okay, next thing then, data. We can get the Titanic3 data set from this link, right, the PASWR, and that's the data set that we just looked at a moment ago, right? So you do need to install that again, and you do need to call it, make it available then in your library. But what we have here then is the information relating to the 1,309 passengers. Okay, so that's now available. And to take a look at what's in the data set, we can use the glimpse command available in tidyverse. And we can see that the variables, there's 14 variables, 1,309 rows or passengers. And we can look at the P-class, survived, 1 denotes survived, 0 denotes drowned, name of the passengers, sex, and so on. And you can have a look here. Some of this is fine. We have a factor for P-class, survived is an integer, name, sex, female, male, it's a factor, that's fine. Later on, we'll convert this to number 0 and 1, just so that we can put it into a correlation matrix. Okay, so finally, what we want to emerge here is just to see what the relationships are in a correlation matrix between the different variables. Some things don't really logically fit into the correlation matrix, like the body of the boat, or the body number, should I say, the boat, the home destination, so on. There are reasons why cabin may not be completely suitable column to include in the correlation matrix. So we will exclude those, and we'll do some manipulation in Python to do that. Deployer, let's execute a deployer command. Just a basic command here to do a little bit of a pivot table. And basically, we take the titanic3 dataset. We use the pipe operator, which is equivalent to, and then group by survived and count. So basically, we're saying how many people drowned, 809, we're counting them and calling it N, and how many people survived, 500 people survived aboard the Titanic. Do basic graph, ggplot, titanic3. The aesthetic is a bar chart, and we can see we have the 809 here in this category of drowned, and 1 denotes those who survived. Now, when we look at this, obviously there's an issue here that goes back to the data set. When we look at survived, it's an integer. We probably should have it as a factor. Okay, so that's an issue that we might address later on, but it's not a continuous variable. It's more a factor. It's binary. You either drowned or you survived. One of the nice features of the Google Colab is you can take that snippet and isolate it, right? And you know, if I do a data manipulation here on this side, you can see that it's happening on this side as well. So if I make changes here, it's occurring over here. What we might like to do is maybe leave that particular graph there and then review other material with a focus back to the graph. So it's a nice little device here, that's our mechanism that's available to mirror the cell tab. We can also put it into a scratch mode where we make some changes here, but doesn't affect the syntax of the original graph. So for instance, I could put in fill. You can see nothing is happening here, but I'm playing around a little bit with the graph, and I'm thinking, what if I could incorporate in here the sex of those who drowned and survived, and we get an interesting picture. It's a little bit maybe more revealing than this one here, and perhaps I would like to park it here and call it up when required. But basically, we're looking again at drowned and survived, and then we're looking at the gender profile. And of course, a lot of males drowned in comparison to females, and proportionately more females survived than males. Okay, so that's something that is well understood from the anecdotage of the Titanic. Okay, so the data we have, I mean, typically we can have a look at the data that we have that we're using by going over to the sample content, sample data in the content folder. At the moment, we've no data here. We just have sample data, but we've no data here pertaining to the Titanic. But if I did want to make available this Titanic3 dataset, I could write it out as a CSV file, and it may take a moment or so. There is a little bit of latency here, but if I incorporate the write.csv Titanic 3, so I take that Titanic3 file, and then I give it a name, and it should be here either. Let's just open and close again. It might be in the content folder. Let's take a look. Okay, it's appeared. Actually, let's go back to content again and sample. Okay, so we can see we have that file here, and that's we can now make use of it in with the Python commands. Okay, so I've used a little bit of R. I've loaded in the data set from a library, or a package, an OR package. That's convenient sometimes to be able to do that, because I understand rather than taking data from the internet without knowing the origins, if we take it from an OR package available on the CRAN repository, then perhaps the data is a little bit more trustworthy, and at least I have documentation describing maybe what's embedded in the data, and that offers a certain amount of clarity. I can then put Python. So basically, we can intersperse or integrate in Python. If I wanted to make use of the Python libraries here, typical ones will be like NumPy and Pandas, Matplotlib, Seaborn, right? And I don't need to do anything except just execute the command, and it'll run in the native Google Colab environment. And that seems to have gone well. And now I want to read in the titanic3. So that titanic3 CSV file, I want to make available to the Python code. So I just run. And when I do that, okay, so I have titanic3, it's available. If I run here, it'll execute and it's available, and I can investigate just the first 5 rows by using titanic3.head using Python syntax. I can get a description, basic statistics using this command, describe with the open brackets, close brackets. Also note here, we've brought in an additional column here. So if we look at our data set for a moment, titanic3, in the process of writing the file, we have this other, we've counted in the 1, 2, 3. So when we exported from R, we somehow incorporated in this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's now appearing as a column in its own right here. So we'll need to drop that or at least understand what it is for the moment, and perhaps edit it out. Okay, so we run titanic3 describe. We have the number of passengers. First, this is an unnamed column, just mentioned, and then we have the others: survived, aged, siblings, parents, children, fare, and then I think it's the body number. Let's check the body number. Right. Okay, so we've run that. We've executed the file here. We can, if we want, maybe put to the side here and take a look as and when required. Let's look at the columns then. So we've 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we've a new column here. Originally there was 14 data set. The unnamed column is this one here, right? And what are the data types? So it's a float, object, integer. Are the data sets? We probably need to drop some of these to run the correlation matrix and make a change on sex to be, rather than male, female, to change it to a number, right? Or that can be read as a number. Okay, let's see how many values are missing in the cell. So for instance, P class, we have complete, we know the passenger class for each passenger. We know if each passenger survived or not. We know their name, their sex. But of the 1,309 passengers, 263 had no record of age. Likewise, with the cabin number, there's 1,014. We've no record. We don't know the 2 passengers. We don't know where they got on. And again, depending if you survived or not, you got on a boat or didn't get on a boat. So there's issues there. Not everybody, there was 809 passengers who survived. So obviously at least that amount didn't get on. The lifeboats, likewise with the body, there's a lot of missing data there. So this is not going to be a useful variable. And then we didn't have records for 564 where people came from and their destination. Okay. So when we're running the correlation matrix, obviously some variables, it makes sense to drop some of those variables. Again, we can run like we did before when we looked at the survival and so on. We're getting the same numbers. That's good. 809 drowned, 500 survived. That's the same as what we observed before. And using the matplotlib, we can generate, again, a similar type of set of data or statistics. You know, it's basically we have the same graph here as over here, except survived, right, and drowned, right? So no difference. And looks like we have a binary data set. They look like factors, okay? Let's run for passengers, we've passenger count. So for each class, third class was the most highest number of passengers went in third class, then first class, then second class. Okay, and we can look at the sex of predominantly there was male passengers and females were a minority. We can look at the number of siblings and spouse. So for each passenger, more than 800, perhaps 900 here at least were traveling alone. But then there was over 300 with either one spouse or sibling, and then dramatically less than. There's a small number of passengers who had more than 2 or 3, either sibling or spouse, right? We can do the same for parent and child. If you're a passenger, did you have parents or children? And the vast bulk were traveling again alone, it would appear. And then those with the higher numbers, there was a few, but they seem to be a small minority here. But in terms of understanding survival, this could have been perhaps important. That's sometimes a thread that's developed in the analysis. We can look using seaborne, where passengers embarked from, right? We can put that up here in the side, and we can consider other things like, say, for instance, if we scratch that, we can say, let's look at P class and the sex of the passenger and run that. And you can see that for P class, we have, would appear we have more males than female travelers by and large. And that's something that probably reflected the economics of the time, that males were more likely to travel as economic migrants, but that wasn't perhaps true for every jurisdiction. We can look at the sex of the passengers and where they embarked. In Southampton, it would appear we had a lot of males, disproportionately compared to females. From Cherbourg, slightly more males than females in Ireland. We have, in addition here, we can look that females actually proportionately as many females as males were emigrating. If we look at the P class from Queenstown, the vast bulk, only a small number embarked from Queenstown. That would have been Cove, County Cork, Ireland. Only a small number embarked in first and second class. The vast bulk were in third class. But the migrants or the travelers, the passengers, equal breakdown between male and females. That may have affected, been influenced by historic norms at the time. Many females with moderate levels of education were able to emigrate to the US and find interesting roles, which much more interesting than the type of careers they could have perhaps embarked upon in Ireland. Okay, so we want to get to the correlation matrix. We can have a look here at what's in the data. We probably would like to estimate a new variable called family size, where we basically add the siblings, the parents and children, so sibling, spouse, parents and children plus 1, and that would give us family size. And when we take a look at this, you can see that now we have a new column called family size, and we'll use that in the correlation matrix. If I run a correlation matrix on this titanic3 data set, the unnamed variable is appearing there. That's really no use to us, so we have to get rid of that. And we probably should try to delete out explicitly ticket, cabin, body, and boat. We're getting a lot of NANs. So to delete those out, just run drop command here, and then we take a look again, and you can see that we don't have that appearing. So for instance, previously, if we look at this data set for a moment, we'll put it in the mirror tab here. We can pull this across. We can take a look at what we have there. We have boat, we have body, we have home destination, cabin, right? We don't need that to appear again. So we drop it out, and we want to drop out also the first column, right? So if I run that and take a look here at titanic5, now it's a new data set. We've have titanic5, but we've dropped a few variables, and plus the unnamed variable. You can see that the unnamed variable has now gone, right? So titanic5 drop, titanic5 has been replaced, has removed the first column here. That's great. And we also need to convert the sex from female male to a number, male as 0, female as 1. And we're going to convert Cherbourg to 0, Queenstown as 1, Southampton 2. And that's to convert those to numerical variables so that it can run in the correlation matrix. Let's see how that executed. Okay, that looks okay. The sex has changed to 1 and 0. 0 for males, 1 for females. We have Cherbourg. If we look at the embarked, Cherbourg is 2. So we now have numerical variables there. And we should be able to run the correlation matrix. And okay, so our correlation matrix is now made up with the numerical variables, and we've created a new one called family size, which obviously has got to be highly related to siblings, spouse, parent, child. We have the fare as a numerical variable. Embarked is no longer Southampton, Cherbourg, and Queenstown. It's converted to numerical, and we have the sex no longer female, male. We have 0, 1. Okay, so if we want to set up then this as a heat map and get some sense, maybe how to interpret our numbers here, you can see survived is positive related to sex. Now sex, it's female for 1, 0 for male. So obviously if you're female, your chances of surviving would appear greater. There is a small, almost 0 relationship between age, but we do find that later on that if you're younger, right, your prospects of surviving better than if you're older, but this is limited to just a few passengers. Not many passengers were really, really young. So there was some children aboard, not so many. And we do know that if you were young, if you're a child, you got preference for getting onto the lifeboats. So there is a slightly negative relationship between age and survive. That might not really reveal the true extent of what the effect of being young was. But if you're in your 20s, it made no difference. But if you were very, very young, it did make a difference. Sibling spouse, slightly negative, right? Parent child, slightly positive. The fare is a stronger relationship. So that would suggest the more you paid, the higher, more likely, it's more correlated with survival. Again, we have to break that apart from male, female, but by and large, the higher the fare, your passenger classification, your passenger class was probably 1 as opposed to 2 or 3, and access to the lifeboats was very contingent on which class, passenger class you're in. So the higher the fare prospects appear, the stronger your survival. Also, if you embarked, again, Cherbourg looked a bit better, but that also coalesces with class. We saw a higher preponderance of first-class passengers embarking in Cherbourg, but it is relevant, but also might be capturing something else, maybe to do with class. And we can see when we look at embarked and look at the if we looked at embarked, it is strongly related to passenger class. And then family size is slightly positively related, but actually fairly close to 0, right? But we do know with the higher families sizes, survival actually deteriorated. Okay, so we could take this data set and write it out to, if we go back into our sample data, if we run that and look at our, we can see that that file is out there now. We can take a look at it, right? We do have passenger class, and we have Titanic 5. Let's run and see what's in there using our command. Okay, I just need to make a small change. I think it should be just the content folder. I'll try that again. Okay, because it's in the, not exactly in the sample data folder, but actually the content folder, I just remove sample class here. We're able to find it and take a glimpse, right? Passenger class is a character here. I should have converted that to a numerical variable so that it would have run in the correlation matrix, right? So that's something that needs to be done, okay? But otherwise, we have a correlation matrix. We have the syntax, the commands, and so on to run the correlation matrix. And that's another powerful way to investigate the extent to which variables are linked to each other. Okay,